Okay, so we are recording now, so everyone be on your best behavior. Today we're going to be going over assemblies, importing CAD from WPI, VEX, and MKCAD. This is day 3 of hardware design training. So let's get started. We just did the warm-up, and I'm assuming you guys all finished that. If you didn't, do it later. So we're going to be starting this. So assemblies pretty much take the parts from Part Studios and then it combines them into a bigger thing. Not bigger necessarily, but it mates them in the correct positions so that they work. So the process for making an assembly or starting one is to import the first part or Part Studio, fix one of the parts to the origin or whatever spot it's in, and then mate the other parts around it. Then you're going to duplicate the parts from the Part Studio if it's needed twice. And remember, you don't put the same part twice in a Part Studio. You only want it once. And then you can duplicate it in the assembly. So these are mates. To make a new mate, you're going to select New Mate, which is in the corner of the screen, or press the M key. And then you can select the mate connectors and flip or rotate the offset as it's needed. So let's do a little bit of working with that. I actually just did this for a friend to show them how to do it. I'll delete all of that. And let's get rid of this. Okay, now it's completely blank. Okay, so this is the Part Studio we made last time. And this is also new stuff. I'll actually delete this last sketch because I'll do it again today. And everything else is new. Or sorry, everything else, this is what we did last time. So we have all of these parts. And when we go into the assembly, we want to insert the new part, Part Studio 1. Let's make it a little centered. Okay, so when your mouse is in this area, it's going to default to the spot where it is at to the origin part, where it is in the sketch. So this is, that corner right there is where I drew the origin for the first driving sketch. So I'll check that. But none of these parts are fixed quite yet. I just got an Amber Alert. That's not good. If there's any missing elderly in your area, please keep an eye out. Apparently, Silver Alert. Sorry, I was distracting. Okay, so to fix this part, you're gonna right-click on it and then press Fix. And now this can't move. All these other parts can move though, because they're all separate parts. So I need to mate them down so that they don't move. And to do that, you're gonna want to mate it in all the spots where you would mate it in real life, because that's like the proper way to do it, so you don't have confusing things. So we don't weld these bars together, so you don't want to mate this face and this side. What you're going to want to do is mate it at the holes in the spots. Sorry, you have to go. Oh, okay, that's cool. Okay, so you're going to select Fasten to Mate, or press M, and you'll select to make connectors. So the mate connectors are automatically given based on the geometry of the sketch. So like you can see that there's a mate connector here. It's this little circle with the axes sticking out. So you select that and then select the mate connector that you want it to go to. So maybe I want it to go to this hole because I want it to connect there. So I'll select that and then they mate together. Now, if this didn't automatically go to the right spot, I could also flip it around or rotate it to make it go in the correct position that I would want. So I'll solve that, and then it automatically opens up another mate, and I can start doing some more. So I want this part to also be connected to this. So I want it to be connected to this mate connector and this mate connector, and they snap together. It's pretty simple, and you can do that for all of them. But now we're out of things to connect because these aren't welded together, so there's no way to connect them. So now we only made one of these parts. So what I can do, well, first of all, one of the things I could do is I can go into this part studio and select the part and pull it out if I wanted another one. Or even easier, since I already have it here, I can select it and do a copy paste. So I can Control C and then Control V, copy paste it around the document. So now I have 3 others that I could put on, right? So well, now I can make them all up and flip that. And then it takes a little bit, but it just works. So that's cool. So now I'm just going to go around and mate all of the gussets to all of the parts. See, this didn't go on the right way initially. I can flip it, and now it's correct. Like this, and put it here. And then for this last one, I can select it here, and then here, it's upside down now. I can flip it, rotate, and it's in the right spot. And I don't even have to mate this to this. I don't have to mate this piece to this gusset now, because this is already mated in place by this part in this gusset, and this gusset is placed here. So this is already in the correct position. It doesn't need to be mated any further. Is everyone understanding this? Does it make sense? Like, do you guys know how to mate things now? Can you do like, yeah, thumbs up? I know you get it, Yuta, but like, okay, I want to know if everyone else gets it. It's like Ashton, Marcus, Pranesh. Do you guys all understand how to do it? Okay, maybe they're still working on their thing. I don't know. Okay, chat, kind of. How do you flip it again? Okay, so, I'll show you. So this is the first mate right here. So when you're doing this mate, in this part, it says flip primary axis. It flips the side that's connected to the thing. The little arrow that goes back and forth. Okay, cool. Can I move on now? Okay, I'm gonna move on.
Hey Ben.
Yeah.
Can you share some of the parts for people to practice with, or I guess give them dimensions of the little flanges that you.
Sorry, I think your volume is a little bit low.
Sorry, I think it's covered with stuff. I was just wondering if you could your way to share some of those parts so that people can practice.
Oh, right. This is in the folder if you want to check it out. But this is also the same. This is the same model that we did last time. So if you have it in your own drive, you can try it.
So is everyone, since I'm not on that, on your,
Yeah, I think Marcus and Pranesh said that they finished it or came close to finishing it. So yeah, I'm hoping at least, because I think that's what they said, but I could be wrong. But other than that, it's pretty simple. So hopefully you can pick it up. Okay, so moving on, this is the last thing we're gonna go over is just importing CAD. So you don't always wanna make all the parts yourself because a lot of them are standardized and you can just kind of get them from the internet or from the stores that we buy them from. So you can just download the CAD off of some websites, and then I'll show you how to import it into OnChip. And I already did this earlier, so I'll just delete this, and I'll delete this too. So I'll show you how to do it. I was working with this earlier. So if I wanted to download a bearing and put it into my CAD, so this is a website that we go on a lot. If you just type in XPro, it should be the first thing that comes up. And you'll go into this sub website. There's a bunch of different parts that you can get from here, a lot of which that we use, like a lot of motors and different things. So bearings is one of the things we can buy. I think we have a different source for bearings now, but it's the same CAD pretty much. Like they're the same size. So you'll go onto the part you want, scroll down to the bottom, and then there's going to be a section called CAD Files. And it shows you all of these very long names that might be confusing. So the important thing to look at is just what size hex it would fit a lot of times. So just look at like the main dimensions that you want, and then you don't really have to worry about the part numbers or anything. So like, let's say I want a 1/2-inch flanged bearing for a thunder hex shaft. It's okay if you don't know what a thunder hex shaft is yet, but it's pretty much it's just something we use, and then this allows us to rotate it. So you don't have to worry about any of these other numbers. You just know that it says 1/2-inch thunder hex flange bearing, and that's the inner diameter for the 1/2-inch. That's what ID stands for. So you can preview the CAD on here to make sure it's the right thing, right? And then you can download it, and it downloads as a step file. Now I already downloaded it. I don't want another one on my computer. So I'll just go back in here, and if I wanted to, I can go press this plus button right here. Or I'll even delete this. I don't know why this is still here. Okay, well, it just automatically makes this folder that you can't delete, so that's fine. So you would import a new thing and go, I think it's in my downloads. Oh, and it's gonna be slow today, isn't it? Okay. I really wanted to show you how to do this. Oh my God. Where did I keep it? Okay. So once the files load for you, you're going to want to just select the file, and then it'll give you an option that says import to Part Studio or import to as its own thing. And you'll just not click anything and just press import, and it'll go into its own folder, and it'll give you a spot for the file and a spot for the part. It's not loading for me right now because my computer is being annoying. So whatever. It can be that way if it wants to. Okay. And that was, I think, the last thing. Oh, wait. Okay. But the important part to go over is that you don't actually need to do that, because there's a huge library of parts that you can get off of MKCAD that will download, even if my computer is slow. So if I go to MKCAD bearings, and it's usually sorted by the names that it has on the XPro website. It'll take a little bit to load. Yeah. And then I can find the same part on here off of this library. Right. So like this is the Thunder Hex 1.125 flange bearing. It doesn't say half inch, which is annoying, but it does say the part number, so 217-4006. So if I go on here, I can see it's the same part number, right? Which is this part right at the end. So that's the correct part that we want. So we would just click it and you import it, and it's right here. And you have a new part in your assembly. You didn't even have to make it yourself. Pretty cool. Now we can just delete that because I don't want it. Okay. I think that was it. So today we're just going to be continuing the drivetrain a little bit further. And I'm going to show you how to get the parts from XPro and make cutouts for them, which is going to be more sketching, but we'll put the parts into the assembly as well. What else? I think, yeah, that's it. But this is going to be a sketch that is, I guess, on the more complex side, but not really. So you guys should be fine. And also, if you guys want to do this bonus challenge, this was really fun for me to do, which means it was a little bit difficult. So if you guys want to kind of explore the sweep feature, which I didn't really go over too much, it's it'll help you out with this. This is some good practice. So without further ado, let's start doing our drivetrain a little bit more. So we want to put wheels into this area right here. So to put wheels in there, we need a bearing and a shaft and a block to hold the bearing in place. But for that block to fit into this tubing, we need to make a cutout for it. So we can actually find that block on XPro, which is the site that we just went on. And then it's going to be in VersaFrame. And actually, I think I just looked up bearing blocks. Bearing block. Okay. So there's a few different options, but the ones that we normally use are not that one, this one. So we use this and this one for the sides, side wheels, and then this one for the gearbox wheel. So we'll start here, and we're going to go into these sketches, and we're going to look at the dimensions that it gives us so that we can fit it into our drivetrain. So where? Okay. So let's start with this one right here. So, oops, let's make a new sketch off of the face of this side. This inner tube, the one that's surrounded by blocks, by both sides and not the one that has an open end. This is the side that you want to put the wheels on. So let's start our sketch by adding a vertical mirror line just in case we need it. And then we'll start CADing out the wheels. So we'll start with a circle, and we don't want to put it in the center because we want it to be a little bit lower so that we don't get stuck. But that's some other stuff. And these are going to be construction lines because we're not actually extruding the wheel here. We just want it to be there for reference. And this is going to be 4 inches, because that's how big our wheels are. We also have 6-inch wheels that we use sometimes. We'll just use 4 inches for this drivetrain. And during build season, if it happens, we'll figure out which wheels we want to use. Like last year, we used 6 inches because we had to go over a bump in the course. Like that was part of our design. Okay, now let's give this a bit of a center drop, and let's call it a 1/16 of an inch center drop, just so it's a little bit lower and this has some tilt to it and it doesn't get stuck or beached, because flat wheels can be bad, especially in a West Coast drive. Now, the side wheels, we do want to be in the center because we want them to be higher up than the bottom wheel. And we're gonna make that construction and make these two of equal size. And then we'll mirror this over onto the other side, right? And then I wanna make all 3 of these. This is the center point, not the wheel point where you're putting it. I want these all to be horizontal and of the same distance. Now, I want to space them out accordingly. So we'll go into this a little bit more next week, but the space that I want them to be from center to center is going to be based on how many links are equal, or what makes like a full link in a chain. So our chain pitch is 0.25 inches, which is some other stuff, and our sprockets are 16 teeth each. So I got about a center distance of 9.5 inches that I'm able to use. And it really works for any multiple of 0.25, I think. So I want to select this for the dimension to the side and call it 9.5 inches. And you don't want to select this bottom one because it'll make a very slight triangle or a very slight angle. And you might not notice it if it switches between horizontal distance and angle distance in the CAD because it's so minimal. But the chain is really, really touchy. So even like a slight difference in horizontal distance can make like a really big difference in the chain tensioning, which is stuff that we'll get into more next week. And these are mirrored, so it's going to be the same distance, and you know where it is. Okay, that was some other stuff. So now let's get back to these bearing blocks that I want to put in. So I want these to be, so how to explain this? Okay, so there's this kind of curved square right here that's going to go into the tubing that you press it around. And then that holds a bearing in this slot right here. So let's make this shape in the tubing. So let's do a rectangle and over the dimensions. You can see right here it's 1.375 by 1.375. So 0.375. And I could make this equal, but I want to display the dimensions, and I also want it to work with the fillet that we do in the next step. So I can do a sketch fillet. That's this button right here, which is the same as a extruded fillet, or I think you would do on a 3D part, but it only occurs in the 2D thing, and it'll show up. It just makes curves, pretty much. So you can set all of those, and the radius is 0.25, which is the one we needed. Cool. So we'll set those. It's all defined. And we also need holes on the outside to mount it. So these two holes also need to be made to press it in. So this presses in, but it also has these two, so you can bolt it in and it's nice and shut. So you have to find the hole dimensions, which is right here. And this is called bolt circle, which is, it follows like a radial path, and you can see where the bolt would be on the outside when you're mounting it. So this is 1.875 inches for a bolt circle. And then these holes are number 10, or they're 1032 bolts, which all you need to know about that right now is that the hole size is going to be 0.191. And if you have any questions about different bolts, I can talk to you about that later. Okay, so 1.875. And then you're going to want a circle that's horizontal to the center of the part, and call this 0.191. And then mirror this over. Now I have two holes. And now I want to mirror the whole thing over so that it's on this side too. So I'll do a mirror, select this line as the mirror line, and I'll just select all of this, and it appears on the other side just like we wanted it to. Okay, now we have to do the hole here in the center, which is going to be a different part. I don't know if it's on this PDF. I think it's on a different one. This one. Right, this is the gearbox bearing block, and we usually put the gearbox in the center. You can also put the gearbox in the back or the front, but that's some different drivetrain stuff, and you can play around with that later if you would like. It's not too complicated, it's just a difference of where you place the double sprocket. But we'll get into that later also. Hard to not talk about these things that we haven't learned yet. Okay.
Are you using a different bearing block because the motor is driving the center wheel only?
Mm-hmm. So this is the block that goes to the, to the gearbox. So in this, on these side situations, you're going to want the block on both sides. Oh, someone is rolling something outside my room. So you want the block on both sides so that the shaft is like retained on both sides, but the shaft is only retained, it's from the gearbox, so it's retained by the gearbox on one side, and then the other block is on the other side. So they just make it different.
And the gearbox is where the motor is housed? Is that what we're talking about?
Yeah, the gearbox has the motors and the reduction for the gears, and it outputs a shaft, which goes into the bearing, which goes into the block, which is what we're making a hole for. So, yeah, I probably should have clarified that. Yeah, so this kind of just goes into the tubing hole that we made, which we'll do today. So this also has a bolt circle, but the part that goes into the tubing is this fat part right here. and that has a dimension, and you can see the side view here, of 1.5 inches. So I can go over, put the dimension at the center of the wheel, not at the center of the center point right here. It can be easy to mix those up. Set that to 1.5 inches. And actually, usually what we would do is even tolerance it a little bit more. I'll teach you about tolerancing later, but it pretty much just makes things a little bit bigger, because when you actually put things together, like it's really hard to get a 1.5 inch piece into a 1.5 inch hole. Like, you want it to be a little bit bigger so that it's a bit looser, but not too loose so that it falls out. So like a lot of times we'll say like 1.5 plus 0.003 or something. So like 3/100ths, I think that's right. I don't know, I'm bad at math, but you know, yeah. And we could also do that over here with like an offset or something, but that would be a little bit messier. Actually, yeah, let's do it. Did I teach you guys offsets? Yeah, so just, you want to just press O and select all the spaces that are going to be offset. And then you can set the offset to the, actually, we don't even need to do that. I think we can just, change this, I think. Yeah. So I can put it to 1.375 plus 0.003, and set this to 1.375 plus 0.003. And that should keep the same thing. Yeah. I was worried about the fillets because I thought they might change, but I don't think they will. And it should change on this side too, because it's mirrored. And I think it did. So, yeah. So now what we're going to do is put a bolt circle, which remember was 1.875. That's a different line. Call it 1.875. Was it? Yeah. This bolt circle hole. And then we can put our circles horizontal to the center of the wheel and call it 0.191, and then mirror this over. And now we're all done with this part of this sketch. Okay. Does anyone have questions about what we just did? Or why we did it? Or why we did a certain thing a certain way?
Can you clarify again why the center wheel is not centered on the
Yes. Okay. So
drivetrain? Sorry, I'm trying to call it what you guys call it. What is the frame
drop? Yeah. Okay. So we call it a center drop because we put this wheel ever so slightly lower than like the actual center of the tubing, which is right here. So when you're driving, like when you have all 6 wheels like flat on the ground, it can get beached pretty easily if you come up to like a ramp or something, and you have like 2 of your wheels stuck on something. So this gives it a little bit of like a tilt so that it can move forward. So these ones are like a little bit off the ground, but not really. So it all kind of, they're all on the ground, but this one's a little bit lower. I don't know. It's kind of hard to explain, but this is just one of those like, trust me things. You want to do this because, yeah. Okay.
It's the ground if you're tilting it.
Yeah. Okay. So anything else? from the audience.
So you drew in, sorry, I'm just going to keep asking questions. You guys chime in when you have other questions.
Yeah, that's fine.
I'm probably the least knowledgeable about robots, so I'm just going to ask. But the parts that we drew, or the rectangle with the filleted edge at corners and the 2 bolt holes, are going to be sent to CNC to cut out, or how is that used?
Yeah, we put them on the, you mean how we cut out the tubing? Yeah, we cut this out on the CNC. So this is, well, this is actually filleted because we wanted it to fit this piece right here. But it works well with the, and I think that's designed because they know that people are going to be cutting it out on a CNC, which can't do sharp corners. Yeah.
The CNC just takes this file, or how does it communicate with the CNC?
Sorry, I think your thing is like a little quiet.
How does the CNC understand to cut these out? Like, is it you convert the file to something that it understands, or does it just take an unshaped file?
Oh, I guess that's kind of a larger question, but yeah, if I wanted to CNC something, I would actually, let's extrude this first, and then I'll show you how to do it. So I want to remove this, and then we'll do it on both sides, even though these aren't the same part, remember. So it's going to do 3 through all, and then in the merge scope, we're going to add this part so that it affects this part also. We're cutting through both sides, the holes affect both sides. Okay, so if I wanted to CNC this, which is not what I was planning on going over today, I would select this space for the tubing, and then do export as a DXF or DWG, and then you just export it and download it, and then I would go into what's it called, Cut 2D Pro, and then you can, I'll show you.
And the fabrication.
Go over like CNCing and stuff, but
you hand it over to the fabrication team, right?
Sorry?
You hand it over to Fab.
Yeah, just hand it over to fabrication, give them the CNC code. Or actually, a lot of people in fabrication know how to do CNC code, so they should be able to do it also. But yeah, and it just comes out like magic. It just appears in our hands so that we can make our drivetrain. Okay, so now that we have these holes cut out, and you can see the spots where everything is supposed to go, we can now put our different pieces in. So let's go into MKCAD, and let's go to Versa Frame, because that's the section of XPro that we're in. When we go here, it's Versa Frame, all of this stuff. Yeah. So what we're gonna want is this thing, right? Because this is the drawing that we looked at, right? So these are actually 2 parts. It's just a part studio. So we'll select these and then group them together because they are mated in a specific way. Okay. So these aren't like flat up next to each other. There is a 30-second of spacing in between them. Otherwise, it would crush the tubing because it's just ever so slightly bigger, you know, just to make us work for it. Okay, so now we can mate it here because this is where the bolt would go, and then mate it to this spot, right? And we can see it all lines up. All right, everything works. Check that, It's solved. Okay, now I think if you guys are okay with it, we can do some linear patterning. I'm gonna check the interference here. It's not, no interference. Okay, so we will linear pattern. Actually, I'm gonna do it on both sides. So I'm gonna copy paste this group, and it's still grouped together. And then we can do it on the other side. Make this spot to here. Flip it and rotate. And we're good. Check interference. No. And the thing I'm doing here is just if Onshape sees that there's two parts that are intersecting, it'll show like some red cross hatches to show you like, hey, these things are like interfering, so you might want to change something, but you have to check it first. But since there's no interference, it won't show anything. So now what I can do is a linear assembly pattern, assembly linear pattern. Okay, so what I want to pattern is this part, this part, this part, and this part. And then the direction is going to be just this line, or actually any of these lines would work, but it's just showing the linear direction that you want to pattern something. And you can already see that like this is patterning right here. And the distance is going to be 2 times the whole, I think we put the wheels at 9.5 inches away from the center. So 9.5 times 2 is 19. Yes, okay. Yes. So 19. This goes in the other direction initially. Thank you, Yuta. I'm sorry, my brain is not good at addition. I can do like all these like complex integrals and derivatives and all that stuff. Not addition. My brain does not work with addition. I don't know why. Okay. Yeah. So those are linearly patterned. And you can also do a circular pattern also, but and it works the same as you would with like a sketch linear or circular pattern. So now we have those two in there. And they're ready for bearings to be put in, which we could even do right now if we wanted. I'm not going to put this part in the center bearing block in yet, because you actually want to put that with the gearbox, and that's how you attach it in there. But we'll get to that another time. You guys are going to like gearboxes. Those are fun. So now I can put in some bearings. Let's go into MKCAD bearings. And if you guys don't know what a bearing is, it's like a little, like if you ever had one of those, the toys that were really popular like 2 years ago, like the fidget spinners, those are the things that it like spins around in the center. Okay.
You have a skateboard, the wheels are also on bearings.
Yeah, skateboards too. So I want a flanged bearing with a 1/2 inch hex. And I'm not going to use the 1/2 inch thunder hex because these are like really high torque mechanisms. Well, relatively high. And usually anything that's driven by a gearbox, it's like an actual motor that's like torquing it, you would want to like an actual hex that lines up with this spot, and not one that just kind of goes into a round part. And you can see this is toleranced also to 0.787. I don't know why they chose that number, but it's a 1/2 inch hex, and you know, it goes a little bit bigger so that it's not stuck. So it's easier to fit in, and you don't have to like really shove it. So I can mate this side, which is this mate connector right here, and just pop it in here. It's backwards, so I can flip it, put it there. And you know what really bothers me is that Onshape does not have mate. It doesn't have assembly mirroring. That's like the only thing I don't like about it. Is that every other CAD program I've used, well, like the two others I've used, like SolidWorks and like Fusion, they have assembly mirroring. So you can just flip it onto the other side. Doesn't do it here. Does not want to. But that's fine. So I would want another bearing, put that there, and let's mate it. That's the right mate connector to this face, flip it, and it's in. And I think I could linear pattern it onto the other side, but that would be kind of difficult to get like the right distances, I think. So let's just, what did I just do? That's not good. Like that. Two of them over here. And it's not the best spot, but it works. Pop them in here. Good. This last one, and then we'll just assembly pattern it onto the other side. Let's do a linear pattern 2. 1, 2, 3, 4. Direction at 19 was the distance, and one in the other direction, and it goes right there. And it all works out. And I think that's as far as we'll go today. Next time, I think we're doing gearboxes and belt reductions and chain reductions also. And yeah, so we'll put in a gearbox into this spot here. And you can also put on some shafts and wheels next time, maybe. So yeah, that's something to look forward to. So I'll stop the recording here.